Many Met Office buildings throughout the country are located in picturesque settings, but you might not associate Bracknell's Western industrial area with these. However, a man-made lake brings a rural touch to the Met Office stores and quality assurance laboratory in Weston Road. Within the Simpson buildings, all incoming stores are sorted and stored, pending the arrival of your store's demand Form 600. The quality assurance laboratory test, and if necessary calibrate, many of these stores' items, ranging from a mercury thermometer to a network of computers. The Quality Assurance Lab is divided into two sections, one staffed by technical grades and dealing with outstation test equipment, electrical systems and spares, and electronic instruments. The second section is staffed by scientists who deal with all the meteorological instruments used not only by the Met Office, but by the Royal Navy, some other MOD departments, and industrial repayment customers. Calibration of an instrument involves comparing it to another instrument of greater accuracy. A means of tracing these measurements to a known national standard is required, and in the case of the UK, this is the National Physical Laboratory in Teddington. Traceability is the method by which small laboratories all over the country ensure that they agree with the national standard, and with each other, of course. In our case, traceability exists for temperature, humidity, pressure, and electrical standards back to the National Physical Laboratory. Our highly accurate instruments are sent to the National Physical Laboratory at intervals of 1, 2, or 4 years, depending. A few instruments are sent for calibration to other laboratories, but these are, in turn, traceable to the National Physical Laboratory. Two pressure chambers are linked to pumps to provide a calibration facility for dial aneroid barometers, used extensively by the Royal Navy. Even these expensive items require the action of a rubber mallet to ensure a correct reading. An accurate digital barometer is used as a traceable standard, and pressure can be adjusted over the working range of 900 to 1050 hectopascals. Dial aneroid barometers often arrive from the Royal Navy in a smashed up state, obviously having fallen off the wall in a storm in the Bay of Bengal. You would have thought they'd use a bigger nail. All pressure calibration is traceable to the National Physical Laboratory by way of a primary pressure standard, an air-lubricated pressure balance. None of the moving parts touch, as they're separated by a thin layer of air, and so there is no friction and no wear. The pressure balance is capable of reproducing repeatable pressures over a wide range at an accuracy better than 0.1 hectopascals. Under a glass dome lies the piston assembly on which weights relating to different pressures can be placed. Since pressure is force per unit area, the relationship between the mass of the weights and the area of the piston assembly is directly related to the pressure generated. Here a weight is being added to generate a higher pressure. The balance is connected to a vacuum pump by way of a large diameter pipe. The Pirani vacuum gauge on the left registers the residual pressure under the dome. The air is extracted from under the glass dome until the pressure is about 0.02 hectopascals, that's near vacuum. This removes the effect of atmospheric pressure and air friction on the operation of the balance. Precision aneroid barometers are the bread and butter of the Quality Assurance Lab, with nearly 1,000 calibrated each year. These instruments are used extensively throughout the armed forces, but their most important role is that of station barometer at the many Met Office airfield locations. Aircraft altimeters are set on barometer readings, and therefore accuracy and reliability are paramount. Much time and effort is spent servicing aneroid barometers, as the many mechanical and electrical parts fail in time. It is worth remembering that some of these instruments are now in excess of 25 years old and require complete updating and rebuilding as parts become time expired or unobtainable. The most common problems are associated with corroded battery terminals and micrometer contacts, but aging cable insulation causing electrical faults are becoming more of a problem. Those in need of major repairs or modification are sent to the manufacturers, Negretti Aviation. A common outstation complaint is that the newly calibrated barometer just received from headquarters does not read the same as several others held at the outstation. This could be due to shocks suffered in transit or failing to allow the barometer to temperature stabilise. However, the usual reason is that the station barometers now read higher due to a slow drift upwards that occurs with time. It is therefore very important to follow correct procedures. A line of up to 14 barometers are calibrated together, linked to a Druck pressure controller by way of pipes. An initial check of each barometer is made at 1000 hectopascals and adjustments made if necessary. If all is well, the pressure is adjusted and readings taken from each PAB and the value noted, either on paper or by direct entry into the computer. The pressure is then set to the next value and the series of readings repeated. This is a time-consuming procedure, and so to speed up the system, an Archimedes computer now controls the pressure system and automatically sets each pressure level. Manually read pressure readings entered into the computer are now collated and a set of corrections for each barometer printed out. The system follows an increasing and decreasing pressure pattern over the range 900 to 1050 hectopascals. This exposes any hysteresis effects. Several types of barographs are calibrated. The Met Office open scale type on the left and the Navy display barograph shown here on the right. The marine barograph is unusual in having an oil-damped mechanism to provide a clean pressure trace even in very rough conditions at sea. These, like the dilaneroid barometers, often arrive from the ship as a kit of parts. Numerically, the biggest task of the Quality Assurance Laboratory is the calibration of thermometers. Some 3,500 per year are calibrated. All types of mercury and glass are dealt with, including ordinary, maximum, minimum, soil and sea thermometers. Most are new and are tested for conformance to the Met Office specification. Up to 14 thermometers at a time are immersed in a liquid bath held accurately at a specific temperature. They are illuminated by a fibre optic cold light, and a video camera relays an image of the mercury level to a video monitor. The temperature is easily read, and the next thermometer quickly selected by way of the carousel fitted to the bath. The temperature of the bath is measured by a platinum resistance thermometer. This is linked to an automatic resistance bridge, which balances the value of the thermometer against a known standard resistor. The bath temperature is maintained by a controller unit linked to the resistance bridge. As the temperature varies about the required value, pulses of heat or cooling are applied to the liquid as necessary. A multi-input scanner unit provides an automatic facility to calibrate electrical resistance thermometer under computer control. A manual method is provided to set a ratio of the thermometer and standard resistances, and hence any chosen temperature. A platinum resistance thermometer is the traceable link to the National Physical Laboratory and is treated with great care. The video system replaced a previous single microscope affair that caused staff a great deal of eye discomfort in previous years. Traditional autographic records are still a Met Office requirement, and so large numbers of thermographs are currently rebuilt by commercial companies and then calibrated in the laboratory. Many of these instruments are over 40 years old, but with regular refurbishment, their original accuracy can be maintained. They are of rugged construction and capable of recording to within half a degree Celsius, and are particularly useful in timing the night minimum temperature. Calibration is undertaken at 3 temperatures between 15 Celsius and 35 Celsius in a heated water bath stirred by a supply of compressed air. A check in an ice bath at 0 Celsius is also undertaken. 2 types of hygrometer are calibrated, the capacitance type and the PCRC. The PCRC consists of a conducting metal track surrounded by a chemical which alters its resistance with humidity. An electrical current flows through the sensor with a minimum reached at 100% RH. The most common use of the PCRC is on ocean weather buoys, oil platforms and remote automatic weather stations. It is fitted into a small screen together with an electrical resistance thermometer and hung from the sensor ring. The hygrometer calibration system consists of an electronics rack to interface the instruments to a display and computer, a cooled mirror hygrometer with traceability to NPL, a dew point generator, and a test box. The dew point generator mixes dry air together with saturated air in any proportion to give humidities over the full range. Saturated air is produced by bubbling compressed air through a bottle of distilled water. The air is then fed into a test chamber in which up to 6 PCRCs may be calibrated together. If you have worked as an observer at an outstation, you'll be very familiar with the hygrograph. It is an unloved instrument that continues to produce data year after year reliably, yet no one uses this information for any practical purpose, the chart being methodically filed away, never to be seen again. This is sad, as a great deal of care and attention is paid to its setting up and calibration in the laboratory. Of course, it must be remembered that after a period of storage and transportation to an outstation, the hair may have altered its characteristics, and so a simple setting up procedure should be undertaken on arrival. In the Quality Assurance Laboratory, the refurbished units rarely work correctly at first, and so after first fitting the clock and drum, the hair is attached to the pen arm mechanism and the span control checked. The deft use of a small instrument is useful for these setting up procedures. Distilled water is applied to the hair and a check made at 100% relative humidity. Several hygrographs are then calibrated together in an environmental chamber. The humidity within the chamber can be varied over a range from 30% to 100% relative humidity. Up to 500 hand anemometers are calibrated each year, and these are issued to Met Offices, airfields and army locations all over the world. Over 50 fixed anemometers are calibrated each year, mostly for installation at Met Office observing sites and on oil platforms. Note the cogging effect due to the magnetic attraction in the generator. The anemometer to be calibrated is fixed firmly into a post in the working section and connected to a frequency counter and voltmeter to monitor the output. The wind tunnel dates from 1952 and was formerly located at Harrow before being moved to Bracknell in 1960. It is capable of producing accurate wind speeds up to 80 knots and is of the open loop configuration. The wind speed is increased from 0 and the speed at which the cups start to turn noted. calibration continues at 10 knot intervals up to 60 or 80 knots, depending on the anemometer type. Many anemometers are calibrated for industrial repayment customers, and together with hire of wind tunnel facilities, generates many thousands of pounds of income each year. A 200 horsepower electric motor drives a wooden 4-bladed propeller, which sucks air through the tunnel. At the intake end, which is the far end, are located banks of honeycomb section grills to ensure a smooth laminar flow of air between the working section. The maximum allowed speed is limited to 80 knots due to safety considerations. At the end of the following section, the maximum speed is attained after 30 and 50 knot stages. Pyranometers, or solarimeters as they are often called, are calibrated in a glass fibre chamber in which 5 halogen lights are fitted around the circumference. These produce an even light level at about 500 watts per square metre and of a similar frequency range to that of natural solar radiation. The electrical output of the test pyranometers are compared to that of a reference instrument with traceability to the National Radiation Centre. A computer scans the outputs over a set period of time and uses an integrating process to enable a mean output value of the sensor to be derived. A computerized instrument administration system has been introduced using an Archimedes computer. This uses a database program to log all incoming and outgoing stores items and is capable of automatically working out statistics for reports of work and accounting and information systems. All QA Lab staff take a turn at admin duties on a monthly roster scheme. Software development has become an important aspect of laboratory work. Engineering and administrative programs are written for the BBC, Archimedes and PC-type computers. And now over to the electronics calibration section, where technical staff deal with a wide range of instruments and equipment. A scheme called MOTEX provides an outstation test equipment calibration service in which a complete set of newly calibrated items are delivered to each maintenance centre and the old equipment returned to headquarters. Here an engineer calibrates a digital multimeter using a voltage calibrator with, of course, traceability to the National Physical Laboratory. The calibrator has a facility for manual or computer control. Here, manual entry of required voltages is seen to be a skilled but time-consuming operation. An oscilloscope calibrator provides a simple, traceable method of ensuring accuracy of these important instruments. The calibrator is capable of providing sine wave, square wave, and ramp-type signals of different amplitudes as required. Computer control using a commercial software package is to be introduced to simplify the calibration procedure. Traceability of frequency to the National Physical Laboratory is attained through a radio receiver locked to the low-frequency transmissions of the rugby clock equipment. The frequency of a rubidium standard oscillator operating at 1 MHz is compared to the radio transmissions and any difference adjusted out. This accurate 1 MHz frequency is now divided down to a working range suitable for calibrating Met Office frequency counters. Voltage sources, attenuators, and decade resistance boxes are calibrated using a Solartron 8.5-digit digital multimeter. The purchase of this highly accurate reference multimeter has simplified this area of calibration considerably. The purchase of much of the new electrical test equipment seen, together with the introduction of the MOTEX outstation calibration scheme, has cut the total workload considerably and, it is hoped, provided an efficient service to our customers. Apart from the responsibility of calibration, the laboratory is tasked with the acceptance testing of many of the electronic systems procured by the Met Office. Many of the PC-type computers purchased pass through the laboratory to be tested for serviceability and are sometimes modified for the final customer. Complete local area network systems, such as the Quattro systems for weather centres, have been set up in the laboratory prior to shipment. This has allowed acceptance testing to be followed by software trials, installation cabling checks, and a complete system test, hopefully avoiding disrupting busy outstations for long periods. All of the Mark IV radiosonde systems, as seen here, pass through the lab for acceptance testing prior to being passed on for software evaluation and final installation. Automatic climatological recording equipment, or ACRE, was another piece of equipment for acceptance tests. And now to Beaufort Park. One of the more unusual jobs of the Quality Assurance Lab is that of radar dipole calibration, a very pleasant task in good weather. The dipole is part of the aerial assembly and transmits pulsed electromagnetic radiation in a narrow beam onto the radioson reflector. The dipole rotates and provides positional information to the aerial control system so that it is capable of locking on and following the moving target. Calibration involves fitting the test dipole and then directing the radar beam onto a cone fitted to a mast at the end of Beaufort Park. The amount of energy received is displayed on a power meter and the dipole choke gap optimized for different transmitter frequencies. A graph of the results is included with each dipole. The new laser cloud-based recorder is another instrument that has come under the scrutiny of QA Lab staff. Electrical and safety checks, together with a short outdoor test, was undertaken prior to a long-term trial by Sensorlab here at Beaufort Park. A rather unlikely responsibility of the Quality Assurance Laboratory is that of the Met Office Instrument Museum. Many of the fascinating sensors and systems of former times are housed in several display cabinets, both in the restaurant block in the headquarters building and in the Eastern Road Annex. Here we can find radiosondes and dropsondes going back to the time of the meteorograph. A fine range of mercury barometers collected over many years are displayed. Fishery barometers, Q pattern and 14, together with many lesser known types. A bookcase and a pile of rubbish? No, this is Mr. Dine's original meteorograph radiosonde calibration equipment, dating back to the 20s. Handwritten notes by the man himself still adorn the back panel. Anemometers, barographs, wind dials, hygrographs, thermographs, rain gauges, recording, tipping bucket, heated. Even fax machines dating back to the era of the valve, a time when paper dried out instead of jamming itself under guide plates and wrapping itself around rollers. The first Met Office servo precision aneroid barometer built by Mechanisms Limited in the late 50s, a complete failure. The Beckley-Robinson anemometer and anemograph, built in July 1893 and located on the roof of the Radcliffe Observatory in Oxford. This equipment remained in operational use until 1976, when it was presented to the Met Office Museum. These pieces of 1940s telecommunications technology were reportedly used by Met Office staff in the process of breaking the German military codes during the Second World War. Apparently, by knowing what the weather was like over Germany, the coded weather messages could be compared to that expected, and the correlation between the two worked out, and thus the code's broken. Finally, a recording mercury barometer, passed on by Kew Observatory on the closure of that great and famous establishment.